Hi everyone, Alex is here. Common mistakes in database creation. Let's start. No normalization. So this is the first example and it's quite easy to understand. So when you're making any table, you should avoid adding specific values to the table that can be moved to another table. For example, here we have orders and we are writing here ID, customer name, customer email, product name, product price. The problem is that you're just duplicating product name, product price. For example, you can have iPhone as in product, and you can have 10 people who you're selling that, and you will duplicate product name iPhone for 10 times. The price could be duplicated also for 10 price if it's the same price. And for example, customer name and email, for example, someone can bought it 2 times, it will also be duplicated. So you'll just duplicate the text so many times that it's incredible even to tell you. So when you're, for example, making an order in Amazon, you're just ID. You're not the full name because your full name is in the another table, and it will help you to just small your space to incredible number of times. Can you imagine that storing, for example, digits, like 5 digits, and storing, for example, 100 letters, and that's for each row, and it can be multiplied in the how many columns do you have. So this thing will save you incredible amount of space. So an idea is here. So you're creating customers, products, orders, and you can see that orders have ID and customer ID and product ID, and all of them, like customer ID and product ID, are references to another table that are connect you to another customer. And if the customer will change the name, it will be automatically changed in all the orders that you had. That's the key idea here. And also you can remember, you can use here 1NF, 2NF, and 3NF methods. So basically, you're looking to the next thing. So it's normalization format. 1F means that you don't need to store some data in one field. For example, you can write here customer, and it could be name, comma, email, comma, other values not. You should store, for example, here, you should store each value separated in each column. So name should be in name column, email should be in email column. You don't should to have one column that calls data and there is everything that you need to have. Not, that will be complicated and it will be complicated to the system. So don't do that. Just separate everything with each column. You can also use blob and JSON formats. You can Google them and you can see that this is really big formats, and please don't use them without really specific need. Okay? So also you have 2NF and 3NF. They're a little bit similar, but they're different. So when you're, for example, creating a table like here, and you have, for example, customer ID and email, like customer ID and customer email, you should always move such things like customer email to table for customers, because you're making references to inside of this specific table, and it will just really make you better realization of the table. So basically, just remember one thing, that you should create main table, and then you should create additional tables to reference the things that you have in the main table. It will make the most impact for your database. Bad naming. So it's quite small one, fast one, but you should understand that it's really important to take time for creating a good names for your accounts, because you'll be using that for a long time, and also it will be used in another parts of your application, especially if you're creating a big one. So please just make a time to find out the best things that you can have, and don't do something like A/B. That will be really weird. So bad naming should be blocked in all the situation. Now indexing. So here it will be a little bit complicated to tell from the first time, but I hope that you all understand it. So basically, when you're taking, for example, the theme, like select everything from the specific email, this one will show you all the columns and the users with a specific email, but here's the problem, that it will just screen full table. So if you have 10,000 rows, it will just scan all of them. And can you imagine how many performance you should have to make that? And can you imagine if you have 1,000 queries like that? It will make a huge impact to your database. So you should create something unique for this situation, and it calls indexing. So what it will take? Firstly, you should take really unique names, because if you'll take, for example, gender, there are not so many ideas of that. So if you'll take that, you should take only unique names, because unique names will create specific hidden column that when you write the specific email, it will check it with database index. It's like an ID. So when you're writing where ID is equal for specific one, it doesn't scan all the table. It just takes the specific ID. It knows how does the IDs are going, and it's going extremely fast to that point. It doesn't scan all of them. So that's the idea. And when you write the same email, like create an index of that, like on the 10th row, you can check it here. So you will make a hidden column that when you'll be filtering that, taking the data, it will automatically take the email and create that to that specific column, and will back your result with your specific user email, but it will be faster because it will create specific columns that you don't see once more. It will help it to scan that easily. But here is the problem, that it is incredibly fast when you have the full name of an email. That will really help you, because it's how it works. So you're writing whole email and it just like encoding that to specific ID, for example, and it know where it can find it in a column. So it doesn't need to go through all the 10,000 rows. It knows like, oh, such ID can be in a 1033rd line, for example, in its database. Here's where you're taking that. Amazing. But here is the problem, that when you're using the specific part of that, here could be a problem. So when you're using, for example, first name or last name for that, it can also be used, even the first and last names are sometimes not unique. So you can use that like here when you're taking the first part of your value, but the other part should be hidden. So such variant will work. But if you don't know that, and you will write something like own or .gmail.com, such variant won't work, because it doesn't know the first part, and the first part in creating indexing is crucial. And here is the problem of working with that. So when you should use indexing, so you should use them when you're making filtering and searching more than inserting data, because when you're using create index, you just remakes all of that indexes, and it will like it will make more hard impact for your application. That's something good. So keep in mind that. And here is the thing that you can really use. It could help you. So it's functional indexes, and it's only for Postgre. It's trigram index, and they can a little bit help you with working with such emails. So for example, when you're working with functional indexing, firstly, you should just not write create index on user's email. You should just write lower email, so the function that you're using. And every time when you will use your, try to search for specific value, for example, where lower email, it will automatically use indexing. And that's functional. So it based on function, because you cannot equal lower email to email. You should always use functional index to make them equal. And Postgre only, so the problem that we have with index cases, so that's a really big problem. Honestly speaking, the best solution here is to use PostgreSQL, because others doesn't have such a variant of working with that. So what will Postgre help you? It uses trigram index, and you can see here that this creates a trigram index on a specific value, and it is slower than simple index, but when you're taking something like that and you use I-like, it will work pretty fast. It will be faster than just scanning all the rows that you have. It won't be as fast as just using index cases with first part of your value of or whole part, but it will be effective when you don't know the first part of your sentence or the whole part of your sentence, know only something in between, or you know some specific parts in between. So this variant will work here really good. Missing foreign key. So when you're creating your database and tables, once more, you don't should just write, for example, user integer and then take this integer and then make a query on your backend to take something based on this index from the another table. You can do that, but the problem is that we have specific references, and what references do? You can make a query in SQL, so it will be faster, firstly. Secondly, it will be more secure, and you can take the relation, this user index, to specific value. And sometimes it can even help you to understand the problem in your database, because some user can be deleted and you can have a permission that such user cannot be deleted if it is in specific value, and such references can help you to manage that thing. So when you're using just user ID integer, it won't work. So you'll be able to delete user index ID, and you'll have a problem because in specific column it is mandatory field, and all of your database could be really down because of such problem. So use please references, it will really help you, at least in the future, believe me. Redundant data. So it is a little bit similar to what we have been looking with non-normalization, but it's a little bit different. So here we have the thing that important to know, that you don't should write specific column, for example, alter name in a books table, for example. You better use IDs. So the thing is here to when you should just use one small column, it could be with any letters or any other things, you should always use ID to reference that. So please try to split your database as many tables as you can, so it will be easier for you to manage them. Because if you write author name in a table book, so such authors, they could be, for example, 10 per all the books, or for example, the one author can make, for example, 100 books, so it will just duplicate the same name, and when you're you wanted to change the name, you should just change in amazingly places. So like it can be 100, it can be bigger number of that, but when you're using ID, it will help you to specifically change that in one place, and automatically it will be changed in that table, because when you'll be referencing the specific ID, it will return you the data from the specific column. So remember, use IDs the most. Try to split your information also as many as it possible. Overuse of nulls. Honestly speaking, all of us have such problem that we're trying to make the table as fast as we can, and sometimes we're really forgetting not to use null. So just remember, try as many as you can to write not null. Why it is important? Firstly, it will just make some confusion to you, and in the future it can be some integration issues. So when you write not null, you'll be sure that some value won't be written without specific data, because if you will write, for example, email, and something will be broken on your backend, and you will store a new user, or for example, no, it's better, you'll create a user with password and email, and for password you won't be using not null. So the problem will be here that, for example, the password wasn't written for some reason, backend problem, or any service was down. So the password will be null, and when the user will write its password, it will have error, and the user will be really confused why it doesn't work. And if the user will change the password, so we have the problem in our database, every time he'll be using such password, it will be down. So it's important, not null. Try to use it as much as possible. Also unique, sometimes it's also good. For example, email should be unique, and because if such user will exist, you will just duplicate the same user, and in some point they will be able to confuse with passwords and etc. So that's really could be harmful. So please try to use not null, unique, and other fields as much times as you can. No scalability planning. So that's also important. You won't be thinking about that from the very beginning, but you should keep in mind that what you will do if the users will be bigger, if you should have more information. So here is one thing. Database, it's really sometimes complicated thing, but there are some methods that are using until now. So it's vertical scaling, horizontal scaling. For example, you can split your database for different servers. You can make, like, I'm speaking a lot of different things. Just check out in the internet, or I will make a video about that. Just write in the comments below. But anyways, for example, here you can see when you're using, for example, data as JSON field, and the problem is that you cannot split the data. You cannot, for example, you understand that you can use email in another table, for example, table for emails. I don't know why, but just let's take that imagination on. Maybe you can use several different emails for one user, and he or she can log in with different emails. That could be, so you'll be using just email ID, and when you're using like JSON, it won't work, because you'll have here first name, last name, email, everything to one place, and it won't scale it up, sadly, but that's true. So please remember about the scaling, about it, how you can do that. Just try to plan how many money you can invest for storing more users. For example, at some place someone can make a video about your application and the users can be just increased in 1 second, but you should know how you can increase the amount. Maybe you should have a scalable plan, so it will have, for example, 5 gigabytes of storage, and that can be really in a second be increased to 10 gigabytes of storage. That could be. So please think about that. That's about scalability. Thanks everyone for looking at this video. So today we have just discovered some basic mistakes for creating databases. I hope that you will learn these lessons and you won't make such problems. And if you wanted to know more, please write down in the comments what you're looking for next, and see you in other videos. See you!